we did in part A this problem right here. Maybe you can read it a little bit better in here, right here. And this was our problem with the initial conditions. And this is how we did it by hand. We had to apply the Laplace, do some algebra, solve for the big Y and the big X, and then apply part frac, which I did it directly in Matlab, and then decompose the fractions a little bit better, match them with the Laplace table, and then do some more finessing here, and then getting the results. Now, I'm going to show you how to do the same thing in Matlab. So here, we're going to give you some space so that you don't see the clutter from other things. And I'm going to clear all the outputs here. The first thing we're going to do is we're going to say what this is. What is it? This is exercise 3, chapter 4.6. Okay, now we're going to clear all variables, clear all. Then we're going to define some symbols. And we're going to use the sims command, and we're going to define the symbol S and the symbol T, and let's say the X and the Y, the big X and the big Y. So the first thing that we had in the problem was our system, and we wanted to solve after applying the Laplace. So what I would do is I would apply the Laplace by hand to the original system, and then have MATLAB solve the output of that. So after we applied the Laplace, we had S times big X minus X equals to minus 1 minus 2 times big Y, right? So we can say that this was one of our equations. And then our second equation, S times big Y plus big Y equals 2 plus 5 times big X. And now we can put these into the solve function, and we can ask it to solve for X and Y. And we want it to output into X and Y so that it redefines them. I'm not going to put a semicolon here. And if we did things correctly, let me see. Sx minus big X plus, because that was going to be minus 1 minus 2i. And here we have sy minus 2, which we brought to the other side, plus y, 5 times x. So now that we do that, we press Control Enter. Forgot to put a title here, and I'll write here, solving for x and y. So now we have this, and we can input this into the partial fractions already. So creating partial fractions. So we can say that our x can be renamed after we apply it part frac of x. And for y, we can do the same. And now we'd have, press control enter, we'd have these things, right? So actually, there was no way to apply part frac to these. But I'm showing you how to do it for other exercises as well. So now that you have these, what you want to do is you want to find the inverse Laplace. Finding the inverse Laplace. So that's going to be the small x of t is going to be I Laplace, which is basically the command to apply the Laplace inverse to an expression x. And the command for y is going to be almost the same, but you got to change the names. And then we press Control Enter, and we see what it outputs here. And we get we get negative cosine 3t minus 5/3 sine of 3t. So I notice here that I might have forgotten a negative sign, and then, yeah, because when I split up the fraction, let me show you. When I split up the fraction over here, see how this negative was in front of both of these? So when I split, this negative doesn't just go in front of the s, it also goes in front of the 5. So this should be a negative. And now, so that checks out now. And now we look for the y part. And in the y, we have 2 cosine of 3t. And now here, I'm supposed to have 7 over 3. I had 5 over 3. So that also may have been a mistake on my part. So now what do you do? Because I had this guy right here. You see how I have 1, 3? And why do I have 1, 3? Because here I just forgot to bring the 7 down and the negative down. So this should be brought back here. And then everything checks out and we get the same answer as Matlab. But if you were not sure, what you could do is you could check the solutions by putting them back into the original problem. So now that you have your x, you can say that your derivative of x with respect to t has to be equal to x minus 2 times y, and your derivative of y with respect to t has to be equal to, remember this is our original system, has to be equal to 5 times x minus y. And you're going to get the initial conditions. So you're not going to get exactly the same thing. But here we have this is equal to that, and this is equal to that. So we know that these are indeed solutions. All right. I hope this was useful, and it was useful for me because now I can go back and tell you guys, hey, I did some algebra mistakes on the previous one. And that's why I like to do it with the computer instead, because I always have that signature mistake. And I'll see you next time.